Every chemical reaction starts on this energy scale. But notice the problem. This ball represents our reactants, and it's trapped. It wants to react, but it lacks the energy to get over this hill. That peak is the energy barrier, and without enough energy to scale it, the reaction simply won't happen. When we add the required activation energy, we give the reactants the speed they need to overcome the energy barrier and form the activated complex. This is a high-energy, temporary state where the reactants bonds are stretching and breaking, and the product bonds are just beginning to take shape. We now have effective collisions. The reaction can proceed. In an exothermic reaction, the products have less potential energy than the reactants. That difference in energy is released to the surroundings, usually as heat. This is why a fire feels hot. The difference in energy between the products and reactants, or enthalpy change, is negative because the system released energy. In an endothermic reaction, the products have a higher energy value than the reactants. To reach this state, the reaction must absorb heat from its surroundings. This is why an instant ice pack feels cold. It's pulling heat from your skin to bridge the energy gap. The enthalpy change is positive. Subscribe for more syllabus topic hacks.